This is an example question on using SUVAT in 2 dimensions. I've started by listing the SUVAT equations to point out that if we move into 2 or even 3 dimensions, we can treat most of them as vector equations. So v equals u plus at becomes the vector v is equal to the vector u plus the vector a times the scalar time. The second one, s equals ut plus a half at squared. S equals vt minus a half at squared. S equals u plus v divided by 2. The only one that doesn't carry across is this last one, v squared equals u squared plus 2as. And that's because v squared isn't a vector. V squared is the speed squared. And so we're not looking at vector quantities. We can still use it in 2 dimensions, but you need to be looking at the speed squared in both the case of v squared and u squared. You need to be looking at the magnitude of the acceleration and the magnitude of the displacement. Now let's put these to good use. The points A and B have position vectors 3i plus 2j and 6i minus 4j. So that one is A and that one is B. The vectors I and j are in a horizontal plane. A particle moves from A to B with constant velocity I minus 2j meters per second. Calculate the time that the particle takes to move from A to B. Well, we can't use vectors for this part of the question. We're looking at constant velocity and therefore constant speed. We've got 2 displacement positions, so we can find the distance between them. So what we'll be doing to calculate the time is saying that the time is the distance divided by the constant speed. So let's first find the distance. The distance will be the square root of 6 minus 3 squared, I'm looking at the I components, plus minus 4 minus 2 squared. And that's equal to the square root of 3 squared, which is 9, plus minus 6 squared, which is 36. And so that's equal to the square root of 45. The speed I can calculate from the velocity. The velocity is I minus 2j, so the speed is the square root of 1 squared plus minus 2 squared. And that's equal to the square root of 5. So I can now say that the time taken to travel from A to B is the distance divided by the speed, since the speed is constant, which is root 45 divided by root 5. And using surds, that's the square root of 45 divided by 5, which is the square root of 9, and so the time is 3 seconds. Part B. The particle then moves from B to a point C with a constant acceleration of 2j meters per second squared. It takes 4 seconds to move from B to C. Find the position vector of C. What I need to use here is S minus S naught equals ut plus a half at squared. And these are vectors, all except for t. Because we do not start at the origin, we're starting at point B, which is the point 6i minus 4j. So I'm going to write S minus 6 minus 4. It's awful dealing with i's and j's, too many letters kicking around, much better to use column vectors. S minus 6 minus 4 is equal to u, the initial velocity. The velocity, well, the velocity when it got to B was I minus 2j, so that will be the initial velocity starting to measure time from B. So that was 1 minus 2 multiplied by t plus a half. The acceleration was given as 2j meters per second squared. So that's 0 in the I direction and 2 in the j direction. And that's multiplied by t squared. Now we're told it took 4 seconds to go from B to C. So I can put t as 4. S minus 6 minus 4 is equal to 4 times 1 minus 2 plus a half times 0, 2 multiplied by 4 squared. So S, well, we'll go straight for equals here. 4 times 1 minus 2 would be 4 minus 8 plus, now a half times 0, 2 would be 0, 1, and then when I multiply 0, 1 by 16 I will get 0, 16. And it finally remains to take the minus 6 minus 4 to the other side, and it becomes plus 6 minus 4. So S is equal to, looking along the top line, we've got 4 plus 0 plus 6, which is 10. And the bottom line, we've got minus 8 plus 16, which is 8. And 8 minus 4 is 4. That would get full marks if I measured that in meters, but I would tend to give it in the form that they give the question, which would be 10I plus 4j meters. And finally, the second part of part B, find the distance AC. Well, A, if we look at the top there, is the point 32. Distance from A, which is 32, to C. Now, what is C? C was the point we ended up at, which was the point 10, 4. That was the displacement vector of C. So here we're just using Pythagoras. This is the square root of 10 minus 3 squared plus 4 minus 2 squared, which is equal to the square root of 10 minus 3 is 7, square it's 49, 4 minus 2 is 2, square it is 4, so that's root 53. Putting that in the calculator gives 7.28 meters to 3 significant figures. And that completes the question.